Hello, this is Mr. Stansbury. I'm going to take you through the notes on domain range and end behavior. At the end of this, you should be able to say I can relate the domain range and end behavior of a function to its graph, and I can describe the domain range and end behavior of graph functions using written words and appropriate notation forms. All right, so first thing, an interval. An interval is an unbroken portion of a number line. Okay, this is an example of an interval. So you go from -2, including -2, up to 3. Okay, so you would say the interval between -2 and 3, including -2, because it's got the closed circle instead of the open circle. Open circle means you're not including it. Okay, we can also describe these intervals using 3 types of notation: inequality notation, set notation, and interval notation. I'm going to show you each one of those. And the way I like to do this is I like to start with the smallest and biggest for each one of these here. Okay, so what we're going to do for inequality notation is we're going to start off with the smallest this will ever be, which is at -2. The biggest it's ever going to be is at 3, and we're going to simply put an x here in the middle. And as long as you always go smallest to biggest, we will be able to use the less than signs. And since -2 is filled in, we would put =2 underneath that. And this here is our inequality notation. Okay. Set notation is essentially the exact same thing with a few extra little pieces here, and you will see this a lot next year if you end up taking the IB class. So it basically just make a little bracket, x such that, and then now we will put in our inequality, -2 less than or equal to x, which is less than 3, and then we close our brackets like that. So again, basically the exact same thing here. We're just writing it with the set notation language here. And then interval notation is basically just where does it start and where does it end. It starts at -2 and it ends at 3. So we do -2, 3, and if it includes it, we're going to put a square bracket around it. And if it does not include the number, we put a round bracket around it. And that is just what we call interval notation. Okay, we're going to do some, we've got 3 examples here. You can watch as many of these as you need, and maybe even try some of these as you go. But express the intervals in inequality notation, set notation, and interval notation. So we have this one here. The smallest it ever is going to be is 1. The biggest it's ever going to be is 5. X goes in the middle, and as always, if you always go smallest to biggest, it's always going to be less than. And then since it includes 5, we will put the underline underneath the 5, but we don't put it with 1 because it does not include 1. Okay, set notation, remember the same exact thing, just with brackets, x such that, and then we copy this thing down. 1 is less than or equal to x, which is less than or equal to 5. And there's our set notation. And then interval notation, start with the smallest here, which is 1, and comma, and we go to the biggest, which is 5. If it includes it, it gets a square bracket, so 5 is included. Square does not include 1, so it gets a round bracket. Okay. B, the smallest this ever gets to is -2. The biggest it ever gets to, there is no biggest, so we just leave that blank. Put the x here, and always greater than, the less than symbol. If I'm reading it backwards, x is greater than -2, but it also is equal to -2, so we would put the equals to. The set notation, brackets, x such that. And we'll do the same thing. -2 is the smallest. There is no biggest. We put the x there. And then we put the less than or equal to and close our brackets. The smallest this ever is at -2. The biggest it ever gets to, if we're doing interval notation, is infinity. You can't actually include infinity because it goes forever, so that'll always get around. Negative infinity and positive infinity will always get the round bracket. It does include -2, so that will get a square bracket. Okay. C, smallest this ever gets to, there is no smallest, so we leave that blank. Put the x in here. The biggest it ever gets to is -3, and it is the less than sign. It does not equal it, so we just leave it as x is less than -3. Set notation, the brackets, x such that, and we'll do, there is no smallest. The biggest is -3, That's less than. Again, it's the exact same as what we did up here, except for we're just including a little bit extra notation. And then interval, the smallest it ever gets to is negative infinity. The biggest it ever gets to is negative 3. It's always round brackets with infinity or negative infinity, and it does not include negative 3, so that is also a round bracket. Okay? We're going to continue with the second half, but before we do that, we're going to take a quick little comedy break.
I went back in, I had to go down to the lobby. I got in the elevator, and there were other people in the elevator with me, and I pressed the lobby. You always expect to go right to your floor, but you ever get out like too quick where you just... And now you're too embarrassed to go back, so you're like, yeah, no, this is what I wanted. Yep, I'm good. The people on the elevator know you screwed up. They're like, sure you don't want to get back on? No, I need the basement. I got to check the pipes. I'm the pipe checker here at the hotel. We're good. You guys go. I'll see you in the lobby in a minute. And you walk over back there and you press the button again, but it's too soon, so the same people are in the elevator when it opens up.
All right. Moving on to the next part here. Now we're going to talk about domain, range, and end behavior. Domain is basically what the x's can be in a function. The range is what the y's can be in a function. And the end behavior is what happens to the y values as the x values go towards negative infinity and also towards positive infinity. Okay? So what we've got here is we're going to find the domain and range of these functions here. Okay, so I'm going to start with the same thing that we did before with the smallest and biggest. So this is really just like what we were doing before with all the notation. Okay, so we're just going to do set notation. So the smallest this ever gets to for x, we're talking about domain here. Domain we usually put as a D, so D for domain. So what can the x's be? What's the smallest that x ever can be? It goes to negative infinity, so there is no smallest. What's the biggest x can ever be? There is no biggest. So that goes on forever and ever. So it's infinity on both sides. So if you ever get that, the domain is simply all real numbers. So we would write this if we're doing our set notation. We're going to do x such that, and then we do x is an element of all real numbers is what that means. Okay? We could also write it with our interval notation. We could write it as negative infinity to positive infinity. That's pretty easy there. Okay? Range is what the y's can be. So the y's, if you'll notice, if we're going this, the smallest we're looking for. So if you'll notice, it's going to the right here. It's going down forever and ever. And it's also going up forever and ever. So it's the same idea. There is no smallest and there's no biggest. So we're going to say y such that y is an element of the real numbers. Or we can say that the range is from negative infinity to positive infinity. Okay? With E, domain and range. So x, the smallest it ever gets to, if you'll notice this arrow is going to the left. So it's going forever and ever to the left. So there is no smallest. It's going forever and ever to the right. So there is no biggest. So that's where we're going to say brackets x such that x is an element of the real numbers. Or again, we can say we go from negative infinity to positive infinity. Okay. For the range, a little bit different because here's our lowest point here. Okay, so the smallest it ever gets to, the y value is at negative 3. And then the biggest it ever gets to, it goes forever and ever up, so there is no biggest. So we put the y in here, and we're going to do the less than. And it looks like it actually equals that, so we'll put less than or equal to. And to complete our notation, x such that not x, but y such that negative 3 is less than or equal to y. Or again, if we're doing it in our interval notation, the smallest it ever gets to is negative, I don't need to print these yet, negative 3 to infinity. Infinity's always got the round bracket because you can't include infinity. And this actually looks like it gets to negative 3, so I would put a square bracket around that. Okay. And then F, domain for this one, what's the smallest the x's ever get to? There is no smallest. It goes forever and ever to the right as well, so there is no biggest. So back to x such that x is an element of the real numbers. And then the range, the smallest that y ever gets to, it goes down forever and ever, so there is no smallest. Oh, here, let's write this in interval notation as well. So that would be negative infinity to positive infinity with round brackets. The range, y such that, and the smallest that y ever gets to, there is no smallest, so we leave that blank. We'll put a y in here, and the biggest y ever gets to, it looks like it's getting really close to 0 up here, but never actually gets to it. So we put 0, and so we'll do less than. And it looks like we probably don't need to put the equals to because it doesn't look like it ever actually gets to 0. So then there's our bracket, y such that y is less than 0. And we're writing this with, writing this back here in the interval notation. Smallest it ever is negative infinity, not 8, but infinity. There we go. And the biggest it ever gets to is 0, but it doesn't include 0, so we put a round bracket. Okay, last quick thing we're going to take a look at here is we're going to state end behavior of the above functions. Okay, so here's what end behavior looks like. As x is approaching negative infinity, so as x is going to the left, getting smaller and smaller, or a bigger and bigger negative number, what is happening to f of x? And remember, f of x is the same thing as y. So as the x is getting smaller and smaller, what's happening to the y? So as we're going to the left here, this is going up. So y is going towards positive infinity, because you can see this goes up forever and ever. Okay, and then as x approaches positive infinity, as we're going to the right here, what's happening to the graph? The graph is going down towards negative infinity. Okay? On this one here, as x is approaching negative infinity, so as we're moving to the left, what's happening here as it keeps going? It's going towards positive infinity. And then as we're moving to the right here, where is this graph going? Also going towards positive infinity, so these would both be as x goes to negative infinity, f of x, or y, goes to infinity. As x goes towards positive infinity, f of x also goes towards infinity up there. Okay, and then this last one here, as x is going towards negative infinity, this blue line is getting really, really close to 0, but it's never actually getting there. So we would just say f of x is approaching 0 because it's getting really close to 0. Okay, and as as x is going towards infinity, getting really, really big, what's y going towards? Y is going down here pretty fast, so that is going towards negative infinity. Okay? Okay, it's all we have for domain range and end behavior. If you have any questions, please feel free to ask in class. Thanks.